All right, I think we are live. I just gotta do my audio checks, make sure the audio is coming through, and then we will get started. Let's see, making sure it's good. But as I'm waiting for audio checks, apologies for yesterday. I did not get to come back around and do the other section. Ended up being too tired. I had to run some errands and just took too long. But okay, audio checks are good. But today we're just gonna continue with our normal routine. We're gonna do 2 sections today. Again, daily, we're gonna do 2 daily sections. These are, as a reminder, working sessions. So I'm just simply building the study guide and trying to educate myself on these topics as I prepare for the exam. In any case, today we're gonna be doing chapters, let's see, 14, yeah, no, not 14, 15 and 16. So 15 and 16 is development and use of clinical decision support standards, CDS hooks, and development and use of data model standards, which is clinical information modeling initiative. So we're just gonna dive right in, always starting off with our good friend Google, see what comes up. I'm already familiar with CDS hooks, so this shouldn't be too bad. But let me see, development use of clinical decision support standards. Maybe not go into CDS hooks just yet. Let me see if there's like, let's see what this one says. Clinical decision support. Maybe we'll just go with this one. Actually, this is not a lot of information though. Development and use. So yeah, maybe we're focused on CDS hooks, because I would imagine decision support standards. CDS hooks is probably the main one that I'm most familiar with, and it probably is a good one. So why don't we go ahead and just do 2 sections here. One is development. Actually, no, we're just gonna do an CDS hooks overview from HL7. Why don't we do this? Go ahead and cite this page. Copy this link. Whew. I don't know how many of you guys are studying for this exam, but it is like an insane amount of content. It's just like insane. All right, we got CDS hooks. It's gonna be a lot to review all of this content after I'm done with the study guide too. But always a good refresher and learning a lot of new things, so it's good to learn. Let's go ahead and link, apply. Oops, that's not what I want to do. I'm gonna link this. All right, go ahead and start CDS hooks. So we're just gonna copy and paste this. Okay, nice little overview of CDS hooks, which we will read in just a second. So CDS hooks is an HL7 published specification for clinical decision support. The site contains the various published versions of the specification. If you're looking for more general information on CDS hooks or the development builds, you can find those at cdshooks.org. Releases of the specification has been formally published through HL7. Ballot versions are the precursors to a release version and go through a period of community feedback. They are archived here for historical posterity. Hook definitions are published with the specification. Note that hook definitions are not part of the CDS hook specification. They are independent specifications that follow the hook maturity model. Hooks are published by HL7. Proposed hooks can be found at It's so fascinating. There's just so much to learn. The CDS hook specification is licensed in Creative Commons. Okay. Where's the more one? This is more general information. Let's go to this website, CDS hooks. So we probably want to reference this. Overview. This specification describes a hook-based pattern for invoking decision support from within a clinician's workflow. The API supports synchronous workflow-triggered CDS calls returning information and suggestions, launching a user-facing smart app when CDS requires additional interaction. How it works. User activity inside the clinician's workflow triggers CDS hooks in real time. For example, patient view when opening a new patient record, medication prescribed when authoring a new prescription, order review on viewing pending orders for approval. When a triggering activity occurs, the CDS client notifies each CDS service register for that activity. These services must then provide near real-time feedback about the triggering event. Each service gets basic details about the clinical workflow context via the context parameter of the hook, plus whatever service-specified data are required via the prefetch template parameter. This is just it's a lot of technical stuff to learn. So EHR med order comes here. EHR triggers a CDS hook and invokes a remote services. So CDS service executes its own rules, leveraging FHIR data as needed. So EHR FHIR data comes through and pulls information. Then we return CDS cards rendered and displayed by EHR. So there's an information card, a suggestion card, or a smart app link card. CDS cards. Each CDS service, so these are CDS cards. This is like the basics of CDS hooks. Each CDS service can return any number of cards in its response to the hook. Cards convey some combination of text, alternative suggestions, and links to apps or reference materials. A user sees these cards, one or more of each type embedded in the workflow, and can interact with them as follows. Information card provides text for the user to read. Suggestion card provides a specific suggestion for which the CDS client renders a button that the user can click to accept. Clicking automatically populates the suggested change into the clinician's UI. App link card provides a link to an app, often a smart app, where the user can supply details, step through a flowchart, or do anything else required to help reach an informed decision. You can try CDS hooks in our sandbox. You know, it'd probably be helpful if I actually built some of these just so I can have a better, more hands-on experience with it. I'd probably encourage anyone who's more interested in learning about this to do that as well. An open API specification, formerly known as Swagger specification interface of CDS hooks, is available. Using the CDS hooks open API specifications, you can generate client or server code. Cool. I think maybe this is good enough. I think I want to pull all this into CDS hooks overview. CDS hooks and introduction. Overview from CDS hooks. I think what we're going to do is cite this page. CDS hooks. Okay. And we'll just go ahead and paste all this stuff in. That's not the correct one. What's this one? Nice. Okay. Let's go go ahead and link this. Just gonna paste all these over. So we have an overview section, how it works, and then I think we have a CDS cards. Oops. Bolt this. Okay. How it works. CDS cards, how it works. Information card, suggestion, and app card. Try it. Okay. I think this is good here, and then maybe it'll be very helpful to save a picture of that. Let's see, where are we saving it to? Website. To where is AHIC? Here it is. This one's called CDS hooks. Alright, so I think we want to post a picture right here. Insert image. There we go. Nice. Okay. I think that should be enough for CDS hooks. I don't imagine you need to know too much more beyond this, but having a basic idea of how CDS hooks works, and I mean this image right here, I think covers the majority of it. But this is definitely something that's on the rise. Like, you see CDS hooks referenced in so many policies, you know, and regulations, that this is something that is part of the future for sure. I think that's all we need for CDS hooks. Let's take a look at this next one. I don't think I'm really familiar with this. So this should be interesting. This will be a little bit of learning. Clinical Information Modeling Initiative. Is that what I was talking about? Clinical? Yeah. Never heard of this. There's a home. Wow. This is a lot. Wow. Okay. I think it was on overview. Let's go back here and take a look. So, Clinical Information Modeling Initiative. Improve the interoperability of healthcare systems through shared implementable clinical information models, a single curated collection. Create a shared repository of detailed clinical information models using an approved formalism. Archetype definition language, archetype modeling language, based on a common set of base data types, with formal bindings of the models to standard coded terminologies. Repository is open to everyone, and models are licensed for free at no cost. Models will support multiple contexts: EHR data storage and retrieval using standard APIs, message payload and service payload, decision logic, queries of EHR data, work products and contributions to HL7 processes, reference information model, shared repository models, formal relationship with groups outside, explanation. The goal of plug-and-play interoperability cannot be met without a common basis for interpreting the data that is being exchanged. In the current environment, significant resources are expended to map one data representation to another to enable data from a source system to be consumed by a receiving system. The lack of common data representations also increases the complexity and potentially limits the capacity to develop and implement clinical decision support. The CIMI clinical information models will provide an isosemantic representation of clinical data that is bound to reference terminologies. From this common modeling paradigm, consistent and semantically equivalent representations can be generated to support a variety of technical implementations. I'm so curious, like, how does this differ from the clinical terminologies? Like, is this like just more robust? I don't think I really understand. Is there like another explanation? Project scope, deference proposed. It was like a long time ago too. Nine-month HL7 investigation. I need something like more. This is from a long time ago though, so I wonder if this is like super outdated. 2016? Yeah, I wonder if this fell apart. This is... I mean, there is like co-chairs. Calls. Upcoming calls. The minutes are not really updated, so I almost wonder if it's like just fell apart. Do we have more information on this? Show 7. Yeah, this is super old. I wonder if this is like predate clinical terminologies. The clinical information model is an international collaboration that is dedicated to providing a common format for detailed specifications for the representation of health information content so that semantically interoperable information may be created and shared in health records, messages, and documents. CIMI members recognize a multipolar world of health informatics and are dedicated to shared vision of universally implementable clinical information models. In April 2011, the HL7 board authorized a task force to focus on how interoperability can be more forcefully, assured through evolving HL7 standards for representing clinical information. Stan Huff was named as the chairperson of this fresh look task force. Over the next few weeks, conversations among members of the task force led to the conclusion that many parties were interested in creating a shared open library of detailed clinical models. It was felt that this group needed to be independent of any existing standards group, at least initially, to ensure that any models developed would be open and free for use. Subsequent meetings were held in 2011 in McLean, Virginia, San Diego, Sydney, and London. These meetings, chaired by Stan Huff, were attended by representatives from 12 countries and from organizations that included standards bodies, national agencies, open source software developers, and proprietary software vendors. The mission of the group is to improve the interoperability of healthcare information systems through shared, implementable clinical information models. The organization adopted the name the Clinical Information Modeling Initiative, agreed on its purpose, and began to publish formal summaries of the meetings and proceedings, a wiki hosted by the Mayo Clinic. This doesn't look like it really progressed. I wonder if this kind of died out. Like 2012 up here, and in here's some more interesting. Guiding principles. Freely available. In 2012, I want to see this. No, it was chosen as CIMI's primary reference terminology, with other terminologies such as LOINC to be used as needed for specific uses or geographies. The members also agreed that the CIMI should be valid regardless of programming language, serialization form, or target reference model. The work of the task forces were reviewed in Pleasanton, and in particular, the work of the reference model task force was accepted as being used to guide the work of the modeling task force. So my thought is that it's an expansion of SNOMED and MOIC. Like it's literally like for certain clinical scenarios, you build a information model about something, like let's say infectious disease, and it references SNOMED and MOIC. I'm assuming that maybe that's what it's talking about. Donation of clinical information models in human readable format for the following. A set of reference patterns in human readable format and computable format. For example, as to blah, 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 contributions of existing clinical models and reference will then be used by CME to provide context for its work. Comparisons between different organizations' approaches to these entities are expected to be instructive. I think what I'll do is I'll copy this, because what is this about again? Development and use of data standard models. I'll go ahead and copy this. Did I reference this? Go ahead and reference this. Let's see. Just give a brief overview of what it is, so this could be a little helpful. Clinical information. Copy the link. I don't know how much more I want to put into this, just because it looks like it died. But let me see if there's any other things I can see on this. Oh, look at this. HL7 logical model for analysis, normal form, release 1. SNOMED, MOIC, ICD 10. Y analysis normal form. So these must be examples. Let's take a look at some of these. Any statements that represent the absence or implies absence of a topic will have a result with an upper bound of lower. Topic, performance, status. In the diabetes type 2 example above, the topic is an observation procedure with a has focus of diabetes mellitus type 2. To represent that it is present, the result of is a lower bound of 1 and an upper bound of infinite, and a measure semantic of countable quality. For more details on the syntax used to represent a result, see the measure class here. See more detailed representation, present in tabular format, see this. So it seems to more, yeah, I guess it's just what it is. You're breaking down how to represent different aspects of various things in healthcare, for example, diabetes, in a structured format, it seems. So it's like the same it's consistently the same across organizations. It's a little hard to wrap my head around. These all look the same. Complete, are these different? How Amphi works. Oh, this is interesting. Systolic blood pressure. So a topic must represent the thing at hand, in this case. Systolic blood pressure has focus. Systolic blood pressure, sitting. Taken on right brachial artery, so the site, using BP cuff of adult size. Patient in a sitting position for at least 5 minutes. Urinated not more than 30 minutes prior to measurement. Sitting position, urination. Urinated not more than 30 minutes prior to measurement. Whew, this is a lot to think about. Example above not only includes a technique of using an adult-sized cuff, but also includes two prerequisites that are represented as separate associated ANF statements. In the associated statements, we see examples of results having a range of values using the upper bound and lower bound. Additionally, while the narrative does not explicitly state that the blood pressure is taken in the sitting position, it is implied by the prerequisite that it is taken in the sitting position based on the prerequisite that the patient was sitting in the position for at least 5 minutes. I have to admit, this is like a little up over my head. Positive screen for fall risk. But it's like same ANF statement. Topic results. Topic result. What's the other one again? Topic results. Topic result. Topic result. And associated statement. Extremely complicated. What was this again? Logical model for analysis. I wonder if this is like even referencing it. Let me just take a look at this. Find common formats for health information by advocating universal standards provides modern healthcare networks closer to. Members include private entities, blah, blah, blah. Together, parties to AMIA attempt to define clinical information standards for items related to diverse conditions and vitals such as heart rate, blood sugar levels. Ongoing meetings help to promote and define consistent standards. Well, that's not very helpful. Ad hoc group that are attempting to enumerate the detailed models of hundreds up to thousands of medical ideas to achieve consensus among clinicians. Plans to make detailed clinical models freely available as unencumbered intellectual property. They could be used as components to define standard messages or structured documents, as components of clinical rules, and to automate or facilitate constructing data entry reporting templates. Okay, this is not helpful. This is not what I'm looking for either. (2018). So this is definitely still going on. Maybe this would be helpful, because this is why to help people live the healthiest life possible. The complexity of modern medicine exceeds the inherent limitations of the unaided human mind. And is not perfectible. There are limits to man's capabilities as an information processor that assure the occurrence of random errors in his activities. We need to provide better care, blah, blah, blah. Fire profiles from AMIA models. I think this is the connection. Smart on fire. So you have your EHRs down here, which reference the AMIA models, the fire profiles from AMIA models, fire API. I'm trying to figure out how it connects. The Clinical Information Modeling Initiative is an HL7 work group that is producing detailed clinical information models to enable interoperability of healthcare information systems, initiating during a fresh look session at HL7 meeting in 2011. AMIA models are free to use. probably want to take a look at this. What? Oh, great. So it's not done. Through shared implementation, it creates computable logical models. The models are algorithmically processable. Yeah, it's still, I don't understand how it differs from like other messaging standards or standards in general, like HL7. Don't they all convey information in the same way? So how are these like different? Models show the structural relationship of the model elements. Models are expressed in a formal computable format. Coded elements have explicit binding to allowed coded values, attributes and values. Models are independent of any specific programming language, implementation technology, or type of database. Models must support explicit, unambiguous query statements against data instances. Shared repository of detailed clinical information models. Repository is open to everyone and models are licensed. Where the models express an approved formalism. Archetype definition language, archetype modeling language. Based on a core reference model, including a set of base data types, have formal bindings to standard coded terminologies. Logical model development. Okay. This is from Sims 2018. So, translators, HL7 Fire, Loin Core Observable, Logical Model Development Lifecycle, Model Dissemination. So you can translate repository of shared models in a approved formalism. Fire resources, core reference model. Still not really understanding. Models are used during software development, which makes the process much faster and more efficient and ensures that the references to data in the software adhere to the agreed standards. The interoperable app development process. Domain analysis, create logical models, approve models, model repository, create physical artifacts, artifact repository. Where are the models used? We want to create ubiquitous sharing of standardized data across the breadth of medicine for direct patient care, research and learning, public health, clinical trials, data from devices, post-market surveillance. More case studies. ISO semantic models, examples of a problem. Suspected lung cancer. So we have problem diagnosis, polyclinic, restructured hospital. Data comes in different shapes. There's a finding, which is suspected lung cancer. There's a finding and location, suspected lung cancer in lung. There's a finding, location, and certainty. Let's say this is the preferred shape. Data standardized in the service. Application and user, data in preferred shape, shape and color transformation, shape and color of data in local database. Partial interoperability, application and user, standard terms, non-standard structures, term translator, local databases. Preferred structure. So this is saying it's data standardized in the service. Partial interoperability. This is preferred. Standard structure. Oh, it's still bidirectional. So what's the difference here? Standard structure and standard terms as defined by CME models. Maybe they're defining the inputs and outputs more, constraints. Standard structure and standard terms and structured translators. Reasons to do it on the server side. Person writing the translation is most likely to understand the meaning of the data in their own database. person writing the translation only has to understand their own data and the preferred model. Query for the data is simpler. If the application has to write a query that works for all shapes, the query will be inefficient to process by every system. Is this supposed to represent something? I think we'll leave it at that. I don't really know where to go from here. SWOT 2016 upcoming calls. Let's see what this shows. So they are like representing different things, but I thought things like SNOMED did this. Maybe I'm like not fully understanding. Model authoring, value set authoring, 600 interim, 6,000 fire dictionary, CME models, conformance testing, AML. Primary reference also be the preferred source. Is for lab. Propose extensions for when needed. Concepts do not exist. Primary version of models will only contain references to value sets. References to value sets. This almost seems like it's structural models versus like the clinical terminologies. Again, I don't see how this is different than existing tools. We will create tools that read the terminology tables and create versions of models that contain enumerated value sets. These sites have been approved. Must be capable of supporting semantic interoperability. Just define parent, enable use. Okay, well, I think I will end it here. I don't know how much more we need to read beyond this. I think this is probably fine for an introduction. I'll probably have to circle back to this. It's probably good to know at some point, but it's a little confusing for me. Well, that's kind of it. We did 2 sections. It finished in less than an hour, which is great. Gonna call it for today. It's kind of late already here anyways, but thank you guys if you tuned in, and I'll see you all tomorrow. Bye.